Um, so unfortunately, because I'm an idiot and didn't start recording, the answers will be all in there. They're also all in the book. We're about to start talking about factorials. Um, there's all sorts of ways that these questions are asked. Sometimes I'm not actually looking for the equals. I'm more concerned with, can you figure out what numbers go where? So evaluate or expand, move them out. Jeez, that bothers me. I don't know why. Calculate. So if I'm looking for, hey, evaluate the following, 10 factorial, well, whoops, apparently I've lost my pen. 10. What's supposed to be a 1? Well, we're going to talk about simplifying down below. Like, try to calculate. Well, I don't care about calculating. Oh my gosh, sorry. That I can just pull up my handy dandy calculator. 10 factorial, whatever, 3.6 million, 36288. That's what that would equal. Whatever. I honestly am not all that concerned with it. One like this, well, I'm going to do, well, I'm going to cheat because I need to be able to draw my straight line. I'm going to write out 12 factorial. I'm going to try to anyhow. So I'm just writing those out when I change to dots just to save space. So that's 12 factorial. Nothing special about that. I'm going to write 9 factorial, but I'm going to go way over here. And then I'm going to do the 3 factorial over here because, and it's a product because that's what is implied there. But the important bit is this back end over here. Because when we come with factorials, whoa, what does that whole big mess equal? 1. Because what's 9 divided by 9? Well, that becomes 1. 8 over 8 becomes 1. 7 over 7 becomes 1. All of these cancel out. So 12 factorial divided by 9 factorial times 3 factorial is equivalent to 12 times 11 times 10. Well, those are left over because the 3's here cancel, but I can't cancel this 3 and that 3 because math doesn't work that way. So 12 factorial divided by 9 factorial times 3 factorial is 12 times 11 times 10 divided by, which if we, because it says evaluate, 3 times 2 times 1 is 6. That's 121 plus 12 is 132. I think. Divided by 6, if we needed an actual numeric answer, that's 220. So this is kind of the trick we're going to use with some of these, especially those ones down there. We can do it with numbers. N plus 2 factorial is n plus 2 times n plus 1 times n. 3 times 2 times 1. Oh, did we pick up Joey? Or is that someone who just dropped out? dropped off. Oh, internet connections. These things happen. So I can't write out everything there because I can't subtract everything. N factorial, well, n. Well, n over n cancel. Everything else cancels. So n plus 2 factorial divided by n factorial is n plus 2 times n plus 1. And if we really wanted to, we could FOIL it and say n squared plus 2 plus 1 is plus 2.
Why do we put the 3 times 2 times 1 at the end?
I usually do just to show that all of the factorials ends up going down to 3 times, like regardless of where they start at, if n is 14 or whatever. It's just a convention to show that we go all the way down to 1.
Okay.
So now comes one that's a little bit different. Uh-oh. Oh, no, I didn't. So n minus 3 factorial. Well, that's going to keep going. Da-da-da-da. N factorial. So these eventually, you're not going to have to write all of these out. We're going to say, hey, I recognize a pattern. Everything down to 1. So we have all of this, everything here. Those go away, those go away, those go away. The ellipses, those cancel, just like if we have polynomials. Now everything in the numerator has canceled. Oh, how did that go like that? We're left with some jump on the bottom. What is left on the top? Well, this divided by this is 1. This divided by this is 1. So we have a whole bunch of 1. 1 times 1 times 1 times 1 is 1. And that would be, if we have a larger number in the denominator, it's going to be 1 over these sorts of things. Slow down. Slow down. Because I have 3 examples and 1 problem. Accessing usernames and passwords. All the things that we have to remember and forget. So try to calculate the value of, if I'm looking at this based on this business here, if I ignore that part, 12 over 9, well, I'm going to start with a string of numbers. It's going to start with 12. It's going to go down, and I'm going to stop 1 before 9. So I don't want to write out 43 factorial because that's ridiculous. So this is going to equal, well, we start at 43. Then we have 42. Then we have 41. And then 40 factorial. 40 factorial, because that's 40 times them. Everything is there. That cancels with this, so we're left with, we can just go through and write out 43 times 42 times 41, and that's what that ratio is going to be. Tomorrow, this will make a little bit more sense as to why we're talking about this. So the next one, yeah, I'm going to break this into 2 parts because there's 2 different things. 55 factorial over 50 factorial. I'm going to start at 55. That was an awful 5 to start, so we're going to start again. 55 times 50. 54. 53. And because there's a 50, stupid head, 51, everything after that is gone. Then I have my second part because that fraction is done. And then look at this one. This one starts at 36, 35, 34, and everything after that is done. So it says calculate. Oh, I don't care. I trust you can use the calculators. But I want to simplify those. I want to pull them out into a string of numbers. So that's how we simplify those. We can do them numerically with a fraction like this. I don't know why I was looking for another word. Well, if the bigger number's on the bottom, we're going to put 15, 14, 13, and everything after that's going to cancel out. But what's left at the top? Just a 1. There's going to be a bunch of people. No, not a bunch of people. Some people make the mistake with having these and seeing this and saying, oh, well, that's 15 times 14 times 13, and just write it without the fraction. But if there's a larger number in the denominator than the numerator, then we have to do this little bit. So far, so good. I don't think I have. I will talk about one thing and then look at the questions. I think there's one that I have to kind of. Just one sec. Oh no, this book doesn't have this, but I like these questions. We'll talk about them in a sec. Solve for n. I have to make one change. That has to be plus, because if it's not, we have a crazy rational function, and everyone will hate me more than they're going to after I finish this. So n plus 2 factorial over n factorial equals 90. Oh dear, what does n equal? Well, if I'm looking at this part, I would have n plus 2, n plus 1. Everything else in after that is going to cancel because we divide those. And then this side is going to equal 90. Then we have a polynomial that we had in grade 11. I'm going to expand this. N times n is n squared. N times 1 is 1n. This is one n plus 2n is 3n plus 2. This is a quadratic minus 88 equals 0. Oh no, it's a sum and product. What multiplies to give negative 88 and adds to give 3. For those of you who forget how to do these or didn't take pre-calc 11, there's a couple of questions in the homework. This is not a common test question, but it is something that you can do with these. 88 is 1 and 88. Wow. 2 and 44. 8 and 8 are 16. 3 won't go in. 4 and 22. 5, 6 won't. 7 won't. Oh, 8 and 11. And that's about it. Which one of these? Because one has to be positive, one has to be negative. I see a positive sign here, so we're going to have, it's always going to be minus plus. If we go this way, which one of those adds up to give 11? Negative 8, positive 11, negative 8, positive 11. Add 8 to both sides. Excuse me, subtract 11. Negative 11. So one of these answers makes sense. One of these does not. I think. Yeah. Which one of these doesn't make sense? Can we have, if we go back to that original expression, which was n plus 2, whoops, n factorial, and that equal 90 or whatever. Which one of these isn't going to make sense? Well, that one. Because if we go back to the definition of a factorial, the expression n factorial, n is defined for only for the values which belong to the set of whole numbers. Is negative 11 part of the whole numbers? Nope. So this is not a valid solution. Now, if I go 8 plus 2 over factorial over 8 factorial, that's 10 factorial over 8 factorial, which is 10 times 9, because the 8, 7, 6, 5, 4, 3, 2, 1 all disappear or are canceled out. When we get to there, 10 times 9 is 90. Negative 11 factorial, you don't believe me, where'd my calculator go? 11, negative, please don't work, invalid input. You can't do the factorial of a negative number. It's not possible. It's out of the scope of the definition of what a factorial is. So that was probably really quick. There are, let's see, what do I have down here? 3, 5. Well, we're going to change that a little bit because we can do 1. There's questions like 1. There's questions like 3. 1, 3, 4, 5, 6. 11 has questions like this. Well, that one's relatively straightforward. N plus 1 equals 10. That one, oh, which should be okay. That one would be a quadratic like we just did. That one would be a quadratic like we just did. But one of those questions, where'd it go? Whoa, that's not good. Undo. Write the following expressions using factorial notation. So this is something we're going to add a little bit down here. Write as a factorial notation. So I'm going to pick a number, 28. And, change colors. 14. So if I want to write this using factorials, well, I'm going to look at each part. I've got a string of numbers. I haven't screwed anything up. Good. What does this string of numbers? These are going to be ratios because I have to cancel stuff at the end. The first number is 28 factorial. What number do we need to put on the bottom to kill 28 factorial after 24? Well, 1 less than 24 is 23. I can do essentially the exact same thing with the other bit. I start at 16. What number is not there? 13. And that's how you would write a string of numbers as a factorial. So we're going to ignore this. So today, in the next 20 some odd minutes, or if you choose to do these tonight, or whatever, I don't know who's still here. We still have 16. We're still doing all right. Let's see. One, I would just write as a string. Well, that one you can write as a string. That type of question is a test question. That type of question is a test question. That one's fun, but write them out as a string of numbers. Number one, that's what we just did. Write it as a string of factorials. Which expression is undefined? There's more than one. So 1, 3, 4, 5. Evaluate, write it as a string. That's funny and silly. Oh, I gotta go find Mrs. Babineau's factorial joke. 1, 3, 4, 5, 6. We'll talk about those tomorrow. 1, 3, 4, 5, 6, and 11. Whoa. Sorry. 1, 3, 4 is essentially a multiple choice or pick question. 4, 5, 6. And the optional is 11. A and B are relatively straightforward. C and D will involve quadratics, like the example up there has. However, they're not going to be ones that you can't factor. Good. The joy of this is, were we in class, we would have done all of that in one day, and you would have had a bucket load of homework. But because of this ridiculous, weird situation, I am not going to rush things. I'm going to export that as a PDF. Again, I'm just going to continually update. Whoa, I do not want to do all of that. 1 to 11, because that's the pages that we need. We are not in my grade 10 class. We're here, we're doing counting. Yes, I want to replace it because we've added some stuff. So I will shortly, stop the recording. If you missed the beginning because you were late, or if you're watching this later, the answers we talked about a little of them, they're all in that file. I think Grace showed up, didn't she? She joined. She was here. That's weird. No one else had any issues getting into here. Well, obviously, because you're all here. It should, in your calendar, like my calendar has all of these. Oh, before I forget, tomorrow I have to reschedule this one. It'll still be within that 1 to 2 hour. I just want to edit that occurrence. I'm going to push this back to 1:15 if that's okay with everyone, because I scheduled my 3rd dose because I got AstraZeneca and I'm one of these trial pigeons. I got that vaccine first, so I'm eligible for a 3rd dose. So I'm going to try to go get it as long as it's still going on tomorrow at lunchtime. But just in case I'm late, if all of a sudden I can't make it, these things happen. But I can access Teams on my phone. I'm not going to have the meeting on my phone. I'll post something that's like, oh my gosh, I'm going to be a few minutes late, or something like that. So give those questions a shot. Tomorrow we'll talk about permutations, where objects are distinguishable, and where objects are identical. Red Bull. So yeah, before I babble on too much, If there are no questions, that's what we're going to do today. And we will see you tomorrow, hopefully by 1:15.